Okay, so I'll go through the remainder of the problems. It logged me out. I had a time limit on myself too, but I'll just run through the rest of the problems. I'll work through them. So the eighth problem was an investigation of the ability of a hybrid tomato plant to produce a certain protein, found that the amount X of protein produced in the plant had a mean of 113.6 micrograms per gram of fresh fruit, and the standard deviation was 8.6. Consider a random sample of 70 hybrid tomato plants and let X bar represent the sample mean. Would it be expected to observe a value of X bar less than 112? Okay. So again, let's think about what's going on, okay? We always go back to the distribution of X bar. This is the key point. The distribution of X bar This thing takes a while to respond sometimes. There we go. So what do we know? We know that for X, right, the mean is 113.6 and the standard deviation is 8.6. So this tells us for X bar, the mean is the same. Mu of X bar is equal to 113.6, but the standard deviation of X bar is equal to 8.6 divided by the square root of 70. That's our sample size. Okay. And we go ahead and compute that. Whoops. Clear. 70 root 1 over times 8.6. Oops. 0.6. Okay. And we end up getting 1.027897. That's our standard deviation. So how likely, remember what that is, that's talking about a percentile, right? So how likely is it to find a value less than 112? So we want to know what is the probability that X bar is less than 112, given that its mean is 113 and its standard deviation is 1.0278. Okay. And we can put this all into StatCrunch now. So we go up to StatCrunch. What's the probability that it's less than? Okay, 112. So the mean here is 113.6, right? And we said the standard deviation was, what did I do with that? We'll say 1.028. There. 1.028. And we want to know what is the probability that we would see something less than 112, X bar less than 112. Okay. And so it's roughly 0.06, right, or 6%. Okay. So how are we going to make a decision? Well, usually we're going to look at P bar. We're going to look at the P value here, the probability in the tail here. Okay, is the likelihood. And we're going to make a decision, and here it's kind of low. So it would be expected to observe, because so it's saying that this is not unlikely because it's not less than 0.05. So remember, this is what our criteria for unlikely is. If the probability we could have seen that event was less than 0.05, and it's not. So that's why we'd have B here. Okay, so unlikely would be if the probability that we could see a value less than that would be less than 0.05, but it's not. Okay, in an investigation of the personality characteristics of drug dealers of a certain area, convicted drug dealers were scored on a scale that produces a quantitative measure of a person's level of need for approval and sensitivity to social situations. Higher scores indicate a greater need for approval. Based on the study results, it can be assumed that the scale scores for the population of convicted drug dealers have a mean of 42 and a standard deviation of 4. And so we have 82 people in the region, and we find out that their mean score is 43. Okay? Is the sample likely to have been selected from the population of convicted drug dealers of the region? So in other words, what we know is that the mean of the region is 42 and the standard deviation is 4. We took a sample and we want to know if it's likely that they came from that region, okay? So again, we're just going to go ahead and figure out what the distribution of x bar is, okay? So we know the distribution of x bar comes from a normal distribution. If they came from the same region, right, then they'd have to have a mean of 42. They'd have to have a mean for the people in that region. And the standard deviation would be 4 divided by the square root of 82. So this is the distribution of x bar. And we just compute that out. Okay, so now we know that x bar comes from a normal distribution. If they come from that region with a mean of 42 and a standard deviation of 0.44173, shall we say. Okay. Now our sample, the x bar, with the actual value of x bar was 43. Is it likely that they came from that region? Well, we would have to compute the p-value, right? So if they don't come from that region, the alternative, we're testing to see if they don't come from that region, would be that mu is not equal to 42. So I'm going to compute the probability in the tail of this test statistic and multiply it by 2, because this is a two-tailed test. Okay? So I'm going to go to StatCrunch. My mean here is 42. My standard deviation ends up being 0.173, and I want the probability that I'm greater than 43, but I'm going to have to multiply that by 2. Okay. So the p-value is going to be twice that, right? So it's going to be roughly 0.0236. That's going to be our p-value. It's going to be twice that. Okay. So is it likely? So notice that, okay, so they're just testing to see if it's greater. Let's see. So we know automatically we're going to reject because the p-values, even if we multiply by 2, is going to be less than 0.05. So let's look at the options, okay? No, because the probability that a randomly selected sample of convicted drug dealers has a probability of 43 or less. Well, we wouldn't be testing that. We'd be testing the upper tail. So that's not a possibility. Is it likely they come from those regions? Well, we know the answer is going to be no. So we automatically know it's B. We wouldn't be testing to see if it's less than, okay? We wouldn't be testing the probability in the tail. The last one, yes, because the probability that a randomly selected has a sample mean of 43 or greater is greater than 0.05, and it's not. It's less than 0.05, so it would have to be B. They're not doing a two-tailed test, but notice that comes out in the questions because the questions are only looking at greater than. So here we're only looking at one tail. Okay. Let's go to the list. Okay. University economists conducted a study of elementary school lunch menus During the state mandated testing period, school lunches averaged 873 calories. The economists claimed that after the testing period ended, the average caloric content dropped significantly, set up the null and alternative hypothesis. So remember, the alternative is what you're trying to prove. So before, the average was 873. He's trying to prove that it's less than. So we know that the alternative has to have a less than sign, okay? The null is always going to have the equal sign. So the only two that have the mu less than 873 are C and D, and the null is always equality. So it has to be C, okay? The null is technically greater than or equal to, but if I can show equal to, I show greater than or equal to. So I don't have to have both of those. Equals enough. All right, so the thing you want to remember is that what you're trying to prove is the alternative. So he's trying to prove that it dropped significantly. So that means he's trying to prove that the mean's less than 873, which means he's trying to prove the alternative, which has to be either C or D. And the way you distinguish is that the null is always going to have the equal sign with it. Suppose a random sample of 25 measurements is selected from a population with mean mu, standard deviation of sigma. For which of the values of sigma and mu, for each values of mu and sigma, give the values of mu bar and sigma, mu x bar and sigma x bar. Okay, so first of all, we have to remember that the mean of x bar is always the mean of x. So these are always going to be the same as the means, okay? So for the first one, if the mean of x is 12, the mean of x bar is going to be 12. We find the sigma x bar by dividing the standard deviation by the square root of n, which is going to be 5. So 3 divided by the square root of 25 is 3 over 5, or 0.6. Same thing. If the mean of x is 144, the mean of x bar is 144, I divide sigma by the square root of 25. That'll give me 5. And then you can finish out the rest of those. That's pretty straightforward. Will the sampling distribution of x bar always be approximately normally distributed? Well, we have to be careful. Remember that we assumed the sample size was large enough. In other words, it was 30 or more. So it has to be B. Okay, we know C's not right because if the sample size isn't large enough, it won't be normally distributed. And notice that the central limit theorem doesn't say anything about the distribution of x, so A is wrong. And again, D is wrong because it doesn't say anything about being 5% of the population. Okay, so we're testing these two hypotheses. And here, mu is the mean number of latex gloves used per week by all hospital employees. Okay, so we want to test this hypothesis given these statistics. So let's look at this. Okay. So our test is that the null is that it's 20 and the alternative is that it's less than 20. And so we're using the fact that S is equal to 11.5. Okay, so this tells us that the standard deviation of x bar is going to be 11.5 divided by square root of 40. And we don't really care too much if it's the standard deviation or the standard, or we don't really care too much if this is the sample standard deviation or the population standard deviation. We're going to say that these are basically the same. So if the null hypothesis is true, okay, if the null is true, then x bar comes from a normal distribution with a mean of 20 and a standard deviation of whatever that is. That's not right. Okay. So now my X bar is 19.1. Notice I'm doing a lower tail test. So notice that the null hypothesis tells me the distribution of X bar. Okay. The alternative tells me the direction of the test. So I'm going to test in the left tail of the test statistic. Okay, so let's go ahead and put this all in the stat crunch. So this is going to be 20 under the null hypothesis, and this is 1.818. And I'm testing to see if it's less than 19. And there's my p-value, so it's actually quite large, 0.2911. Okay. And they get a little different answer. They probably didn't round off the standard deviation. Okay. They actually used the t-distribution. That's okay. It won't make a big difference. It'll be a little bit different. And then they want to compute the p-value, compare the p-value with alpha. And so it turns out that the p is not less than alpha. So we're going to fail to reject. So there's not sufficient evidence. Okay, that looks good.